Hello everybody, this is Brad Dyke reaching out to you again, saying hi, and today's topic is the reorganization of my two rack enclosures. As you can see, they're mobile right now, and I'm going to empty them because I'm generating some significant heat, and the goal is that, my disk arrays, my interfaces, and so on, they generate a level of heat that's realistic. That means basically realistic means that it is not an over amount of heat for the arrays, but it's significant enough to say, okay, let's look at the BTU outputs of each server. And BTU basically refers to the increment of heat levels that are exchanged between something hot versus something cold. So with that being said, as you can see, I'm starting to empty out rack enclosures of their servers, their disk arrays. Down there is a miner, 3-par. Those 3 boxes down there, I'm going to probably relocate them totally to another location altogether because the Sun 240, the RLX chassis, and that old compact server are just nostalgic machines that I don't want to get rid of. I'm keeping them because they bring back memories. But the 3-par, the NetApp component, I sold my 3270 NetApp, which breaks my heart, but had to do it. Just was coming to end of life, and I'll figure something else out. Plus a NAS array, the Isilon, the prototype platform, the generalized connectivity up here and SAN connectivity, and then down here, as you can see, the other Isilon down the bottom, the 52 disk array, 3.5 inch chassis, the miner. And I've got my compute nodes down here, as you can see. I've got my traditional DL385 here, G6. That's going to transition to this box, and I'm going to repurpose this one. Probably, I haven't decided yet if I'm going to keep it or not, but I'll miss it when it goes. And of course, this may be the new home for the disk arrays that I have in operations. So, as you can see, I have a lot of stuff that I use, but I'm going to be reducing it down to a smaller footprint. This will be a 2-part video. The first part is the disassembly, and then of course the second part is what will it look like and why I schematically designed the BTU outputs of these chassis based on their tech specs to what my HVAC unit can handle, along with the concrete. Concrete's super important because it's a major exchange of heat and cold. And these are some values that you should take into consideration when you're doing a home enterprise-style racking enclosure, is to take full advantage of your environment, such as reflective surface areas for EMP evac. It also helps with some of the heat. Heat doesn't hold on the reflective surfaces like they would on drywall over here, which drywall does hold heat. You want to be careful about how much drywall you have in your environment. But outside of that, I hope you guys enjoy this. I will pause this and do some work. Okay, as you can see, the deconstruction's going pretty good. As I was doing this, I thought to myself, you know what, we have an issue here that probably you may make the mistake on. And yeah, granted, I got a lot of mess here, but when you look at an enclosure like this, you really want to think, how about I put some fans at the top and let them run? Well, there's one problem with electric fans, specifically these kind of fans. They make heat. Actually, they make a lot of heat if you're not careful. So I don't run this unless I have to. This is an emergency backup flow. And I don't even have it on my second rack, if you can see right there. It's in the clear. But I wanted to stop for a second and make mention of that as I begin the process of taking the rest of these units out. I wanted to make sure you guys knew that. Now we have this one down here, the miner. These two right here, which are Dells. This is the family of the HPs. These are G7s. And then I'm going to be moving some equipment over, like the 56-port specialized Nortel switch over. And I have a brand new replacement, by the way. It's here somewhere. Yeah, it's down there. A brand new Microtech 10 gig switch, which will actually house the bulk of the transportation and communication between these servers. I don't need a 10 gig connection for my desktop to the servers, but I do want 100% on my 1 gig connection. And one way to do that is to let the servers talk at 10 gig on their local communication bandwidth, and only the outbound will be able to function, and that can run at 100% because they're not sharing any of the bandwidth with the servers. But I wanted to show you that setup before I go any farther, and I wanted to explain some of these things. So stand by. So another important detail here, as you see we're getting down to the last couple of boxes, is that you notice that this time I'm not doing my camera widthwise, and there's a reason why, and it's actually because of this. To be able to do the full scale top to bottom view opposed to trying to do it sideways, this will mess you up. But if I try to do it like this, it doesn't quite work when I do my video work. So for this one particular video, I'm taking that time to do this time in a vertical video format. One other recommendation to do as well is, if you notice here, the slide rack rails, I put on the inside of the rails the names of the types of servers they work with, so that way when I start collecting them over to the side, I don't get confused and put the wrong sets in at the same time. But the hill is definitely building up, isn't it? Anyways, stand by. Okay, so this is going to come to part one, the end. And as you can see by doing the vertical shot, how nasty things can get really quickly when you're doing a reorganization of your servers. So over here is the giant pile of switches and servers, as you can see here, as well as my behemoth 57 drive or 56 drive Isilon platform, which is the heaviest box because it's just filled chock full of hard drives. You don't pick that one up easily. But I'm going to be ending this session here, letting you see what it looks like at this point in stage, and then when I come back, you'll see how it's reorganized and structured for future use. So, hope you enjoy, and again, sorry about the format of the video, but it had to be done. I'll let you go, bye. Okay, as part two, as you can see, I'm in the process of rebaselining the rack enclosures. I'm switching back over to landscape photo imagery so you can see what's left on the second rack. Here's the Sunfire 240. And then below that is an RLX Telcom blade chassis. I'll show that to you in a second. So this is an RLX chassis. It's one of the grandfathers of what we call blade technologies these days. And as you can see on board in the blade cards, they have the processors in there and the memory, 2 hard drives and so on IDE interfaces. And as you can see inside there are many that exist, 16 of them roughly actually. I kept this because I remember the standing on how blade technology began at the very beginning. And this is one of the standards that existed out there along with the 2600s. You would know them now as HP blade servers, because HP bought RLX to get Control Tower. They used Control Tower to do the imaging on their blade platforms, and then they realized, secondly, that actually RLX had one of the best industry standards out there when it came to blade cards or blade servers. So they became a precedent. So I'm going to relocate this guy over here on top of the Sun server. I'm using it principally for ballast or weight, so that I don't have any leaning effects that happen as these racks get repopulated and grow, especially with the disk arrays. That worries me a lot. So I'll relocate it here in just a minute. Okay, got the RLX chassis moved over. Got the old Compact platform still in place. This is a Pentium Pro dual processor SMP, the first generation roughly of the P6s that were out there that had the actual separated SMP bus motherboards. Really nice chassis. I decided to hang on to it, and it does still work. Boots up server 2008 very slowly, but it does work. And it also has a very special hard drive in it, known as a Seagate 181 gig SCSI 3 hard drive, which is extremely rare because only a few thousand were made before they stopped making them. Though it's got some history in it. But I'm going to leave it in here as is, for I'm going to be rebuilding these racks to meet the requirements I need them to do in the future. So that was just a heads up real fast, and we're going to go after the cable management next. That's quite a mess, and get that addressed. Okay, so we've got everything cleaned out except for the base. And we're back here now looking at the RGB. I use the RGB to try to avoid using the bigger lights as much as possible. They do a real good job of lighting up the cabling. But also something else that's very valuable is your grounding structure. You want to pair your grounding off, keep your racks grounded. It's just an alternative way to source yourself out in case something happens. This is important if you get like a Microtel style 10 gig switch. You have to do grounding on the back. So as a reference point, you'll notice here is a grounding bolt, and that can be grounded out to the chassis of the rack and therefore give you the added extra security you may need for devices that seem to be very sensitive. And I do think the 10 gig switches are very sensitive to variations in voltage. Okay, so if you look here, as you see, I'm doing the build out. The last two, the 4U footprint basically at the very bottom is weighted using older technology that I don't use anymore. Of course, there's my eye salon. I've got some breathing space. And if you look here, you'll see that there is a gated style 1U filament in there. This Dell 720 XD will be connecting to this NetApp series reduced footprint disk drive array, which has no disks in it yet. I'll take care of that soon enough. But anyways, point is that these units are separated because there's a problem with our micro style data centers that people are building, is that with small footprint servers, you have what we call dead zones. Now these dead zones are not really dead zones, but what happens is, as you can see right here with these two as a great example, these two and the newer version with the 3-par, they're right on top of each other. But down here, they're not. And the reason why is because microconvections, those are tiny little air paths that will exist, will formulate and ventilate hot air, exchanging it for cool air. Unlike these two, now this is a system that I'm going to migrate off of, and it's going to go over to here. This chassis runs hot, but this chassis doesn't. So I can actually put this on top of this and not worry too much about too much micro heat buildup. And you're thinking to yourself, why do you care about micro heat buildup? Well, let me explain. Micro heat buildup in an environment that does not use what we call full circulation adaptation. And that means basically the cold air comes from the bottom, blown through to the front, and is exited out of a control mechanism up at the top and put into what's called a recessed heat exhaust system. In other words, you're pumping a lot of high volume air in a data center using Lieberts and so on and so on, 50-ton units at a time. And that's not your garage lab or basement lab. You got some type of HVAC solution, I hope. We're using the house's HVAC solution, which is not the greatest thing to do. And it's doing what we call the circular rotation in the ceiling, pushing cold air up to the top, letting it drop down to the bottom. And the concrete floor helps a lot because it keeps it cool to a point. And then the heat exchange can occur. Now with these microzones, you get better ventilation with your limited HVAC. Okay, you can get these things really cheap. They're about $5 each, $10 on eBay. They're fully perforated. And yes, there are times where you want to control airflow. We want to force it and travel up and mix. So I put these 1U fitters in here. There's 1, 2 here as well. And a miner is going to go down here. He's going to suck a lot of heat all by himself. So I want to make sure he's not a problem. But I want, as we go higher and higher and higher, I need to mix air more and more and more. So that's one of the reasons why I'm doing this way. So I'll move over to the next stage, and that is going to be iStocks. Now, these little iStock arrays are pretty sweet if you know how to use them correctly. They've got 4 drives in them, and these are 2 eSATAs, and this is an archive USB 3.0. And these connect directly to this chassis here. And these are the archive drives that I periodically use, and these are the high performance drives I use for all the heavy duty stuff. Now, this functionality is going to move down to this array, which is already ready because it has a lot of disks in it to act as my new high-end core platform. And then over here, this guy is going to act as an archiver, and of course this guy here is a NAS with its disk. So why do I need this? Well, I'm an architect. I'm an architect with NetApp. If you know NetApp, then you know when you design environments, they have a lot of challenges to them. And that one of those challenges that exist relates to the fact that you are always constantly dealing with new storage services, functionality, cloud services, and all of these servers I have here on the floor provide that emulation. And I mean literally emulation. So that emulation allows me to bring these resources in, and I can become more competent and more functional over time, which normally most of us are so busy we don't have a chance to do that. But I've made it a long time ago a discipline to do this. So more to come. Okay, at this point in stage, both sides are built out. As you can see, they have started the process of booting and configuring and so on. I'm leaving the top sections on the clear for now because we're going to pursue some other things down the road. Up there are the Dell 720 Dell front ends. They don't fit so well, so I flip back to the Googles for now just to keep the fronts protected. This went out really well. It's very flawless. Very impressed with it. Simplified a lot of stuff. As you can see, the configs are clean, ready for the ability to do stuff. I haven't done the wiring yet for the storage capacity, but I will get to that. If you look back there, you can see the SAS arrays and all that. And then over here, same setup. I'll talk to that in a second. But power feeds, DAC hats, SAS arrays on the bottom, and so on and so on. So basically, what we're looking at here is a different type of configuration. I had 3 or 4 switches in the game. Now I only have a big single switch, thanks to a friend of mine. I've recycled some of this gear over the years with churches and so on. But some of it's come back to me. This is mine. I bought this. This is a 10 gigabit switch. The inbound internet connectivity is coming into a 10 gig one port. The important thing about that is this is the actual breaking point of this lab to the rest of the house. So I'd rather have the 1 gig / high speed bridging staged opposed to not staging it. So that was critical to me. And I still get my... Okay, so I got cut off there. So again, we'll go over this one more time because unfortunately I got a disconnection. But as you can see, the KVM's up here, which is an OmniView Belkin 10 gig switch, which has the inbound internet connectivity into it. Yeah, I know it's a 10 gig switch, but it's it's a 10 gig port I lose. But the key thing is that port goes over to a 5476, and that is high speed, very high speed. So by using this 10 gig bridge here, from this, all my IP connectivity will be really fast, running through a 10 gig switch. But there's also one other thing, which you don't see, and that is I have right here another 4-port 10 gig switch, and all the data movers are on that one switch. So if they communicate with each other on a single isolated 10 gig switch that does have 10 gig up to the 10 gig loop, which is right here. So other servers can get a really nice performance, but I want these archive heads and I want these large platforms here to do what I need them to do and do it fast. So for now, I'm not done yet. About to put the upper sections on. You can tell that these are my homegrowns because the gaps that happens when you have to improvise on rail kits. But what isn't is obviously starting from here down. Very clean, very professional. Wiring is going to come in next, and that will get trunked as normal. And just in general, it's just going to be a good overall performance, I think. I'll get about 45% improvement because I've eliminated these older switches, which are down here, 1 gig switches, and of course my ProCurve 100 gig switch, a 100 meg switch. But the whole goal here is to centralize on about 8 nodes total, with ability to flip-flop from archiver to testbed as needed. I just have to flip the KVM cable. And at this point in stage, I think we're doing pretty good. I'll let you go, and I'll finish the rest of this up. We'll get our video in place, and we'll be in good shape. Stand by. Okay, so we now have a cloud-centric enterprise redesign of the lab. It took about 3 days to get everything organized. As you can see here, KVM's at the top. Microcirculation zones are established. The 10 gig infrastructure is here at the Microtech 10 gig. The high-end 56 configuration Nortel switch with the 10 gig uploads. My nodes, limited set of nodes on this side, an expansion-based IP-based storage device with its secondary bay, SAS basic. The new Dell footprint, along with its NetApp, I think it's a 2246, along with its brethren, over here set up the same way. Down there is a miner. It does its own thing altogether. Then we have the cloud interfaces here. You can see the 3-par feed to the HP box. You can see this cloud node, and the 2 test beds that beat up everything out there. So you remember what it used to look like. It was basically an enterprise-based data center mini format. Now this is a cloud-concentric format with free-flowing resources, highly reduced network structure, both on the back end, the front end, and the DMZ side. Using a pfSense style firewall device for VPNing. That works out pretty nicely as well. That's not here, it's down in the basement. And look at all the gear I took out. You know, I had a nice reduction. I reduced the footprints. I had to retire a server, a DL385 G6 AMD. Used to be a storage platform, but it's just too antiquated for what we want to do. As you can see, my network switches and my additional Belkin KVM, lots of wiring. It's a lot cleaner in the back in regards to what I like, and very professionally well tracked, marked, tagged, and so on. So as you can see here, everything is nice and clean and concise right down to the bottom. Over here is the infrastructure side. Again, nice and clean pathways to get to our nodes and accomplish all the goals we want to do. Now, having a cloud-based infrastructure allows me to be able to test the advanced functionalities of cloud interfacing, AWS, tiering, Glacier, pair, deduping on the cloud side, compression or algorithms, configurations, things just designed to help tweak it out as much as possible. So with that being said, that is the end of the rebuild of my home data center. I hope you guys have a great time. This is Brad Dyke signing off. Take care.